you're looking at the beginning stages of a solar generator that I'm making. And these packs, pick one of these up, are going to be 7S 11P. And each one of these C-Max, this is out of a 2015 Ford C-Max, probably a plug-in hybrid, are 23 watts. So this particular, all of these put together are going to be about 1.4, maybe 1.5 kilowatt hours. And that is if I charge them up to 4.2 volts, which is max, and deplete them down to 2.75, which mains down to 0. I do not recommend doing that, but that's how they rate batteries. So far, these things cost me about $400, as you see them. These are 5mm nuts that I took off. The nuts that came with them take a 6.8mm socket, and you have to press down on it and make sure you got a firm, then twist them off. I am replacing with a standard 5mm nut that I purchased. So it'll be easier if I have to take it apart. I decided to put this in a 24 volt system. Actually, it's going to be 29.2 if I charge them all the way up to 4.2. 29.4, I guess, would it? Yeah, 29.4. And the reason being, because I had a 12 volt pure sine wave inverter I was going to use this for, but then I'd have to have 3S, and that would limit it. If you brought it all the way up to the 4.2, you get what, 12.6 volts, and then you could, and the inverter would probably shut off probably at 11. So I would be working with a 1.6 volt range, and the 24 volt system would allow me to use the full scale range of the batteries. So I elected that, and I bought another inverter, and that inverter was about 200, that pure sine wave inverter was about $235. So far, this case cost me $40, and this is a waterproof case with rollers. I got it at Sam's Club. So the case $40, $400, and so you're wondering, why didn't I just buy one from Costco, which they sell a 1 kilowatt. I think it's a Kodiak. I'm not sure what brand it. I can't remember what brand it is. I know it's a 1 kilowatt, 120 volt. You know, it has a 1500 watt inverter, the same as the one I bought. Pure sine wave you can go up to 3,000 for like 8 seconds. But I mean, it's the same inverter. But I don't know how they can get away with it. This thing probably weighs, when I get done, over 40 pounds, and theirs weighs 20. I wonder what kind of lithium batteries they're using in it. Anyway, would I recommend buying these type of batteries for a solar generator? I don't know. I like it because they had these bolts you could screw on. That's the only reason I'm attracted to it. I think these are quite inefficient compared to 18650s. I think it'd be better to build it out of 18650s, which I have thousands of them. But I decided to do it this way because it'd make it easier to make the connection. I'm very, very secure with these bolts. So this is a total experiment. And when I get this thing completed, I'm going to video it, and I'm going to plug it into my bolt and see what extra miles I can get out of this 1.4 kilowatt pack, which you could actually throw in your trunk if you wanted to, if you needed a reserve. But remember, it weighs over 40 pounds. So that's, it takes energy to move weight. So keep that in mind. But I will test it out, and when I get this all bust up and hooked together, I will video it. I've got the packs put together. Now there's 7 in series, and there are 11 of these in parallel. And the total voltage is 29.1. That's the output voltage right now. I charge these up to 4.1 something. I think 4.15. I did not charge them up to 4.2. So the next question is, as you see, I put insulation in between here and here, and these bus bars are a thick plate that came with these batteries. These are connectors for the actually came out of the car. This is just 1/2 inch, pretty thin aluminum, copper, folded over twice and then drilled out, marked them as I put it next to this and put a little mark and drilled them out. A little bit bigger holes in the bolts themselves. Remember, these are 5mm. There's the last one. I got to put some stuff right here. And here's the end cable. I've not hooked it up to the inverter yet. And here comes the test. The car is at 88% hilltop mode, 180 miles. So, cross my fingers. We'll work on this live here. Alright, I've got the inverter hooked up. This is a reliable 1500 watt, 24 volt inverter, and it has never been turned on. The first time I've ever had one of these. And I'm going to turn it on and see what happens here. Alright, another thing I want to show you is that, you can see this, it says I have 171 miles and it's 88%. And I've taken it off hilltop mode. As I mentioned, this is probably 1.5 kilowatt hour pack. We've got a red light here. I have no idea what that means, and we have a red light here on my charger, which means we have a failed thing, and I think it has to do with ground. Okay, I've hooked it up to a 6S rather than a 7S configuration. Now we're at 24.8 volts. I'm going to see if it works in that. So let's plug it in. No, it does not work in 6S either. It's got a red light there, even though it's the right voltage. I'm sure it's a ground issue. Just to show you that this will work, I have a 3-prong cutoff saw. This is 13 amps. That's a lot of power. So it's going to max out this unit. And I'm back on 7S. And so it's at 28.9 volts. A little red light is flashing, which means it's probably over voltage, but here we go. Quite noisy, but it does work. But it's almost pulling out all the amps that this thing can do on a normal 1500 watts. Anyway, so if you have a solution to my problem about the ground for an EV plug, let me know.